Hi, welcome to today's flip video lesson. Today we're going to be talking about Boyle's law. It's closely related to Charles' law. Both Boyle and Charles' law have to do with gases and how the relationship between pressure, volume, and temperature. For Charles' law, pressure stays constant, and we're talking about the relationship between volume and temperature. But for Boyle's law, temperature remains constant. And we're going to talk about the relationship between pressure and volume. And a good way to remember this is this. Charles, think King Charles. And to be king, there's a lot of pressure. And the pressure is constant. So Charles' law has constant pressure. You're only looking at temperature and volume. For Boyle's law today, think boiling water. We know that water boils at 100 degrees Celsius or 200 degrees Fahrenheit, 212 degrees Fahrenheit. So for us, we can say that's a constant. So for Boyle's law, temperature remains a constant, and we're going to focus on pressure and volume. And as we can see from the graph, as your volume, or rather as your pressure increases, your volume decreases. Pressure goes up, the volume goes down. As the volume increases, the pressure goes down. And a good way to remember this, think of a house. Think of me inside the house. Or if it works for you, if you know the first Star Wars movie, think of when the characters got stuck inside the trash compactor. So imagine I'm in my house, I'm watching TV, and the walls of my house start to close in on me. Okay, my house is getting smaller. The volume of my house is now getting smaller. All of the air inside that house needs somewhere to go, but it can't escape. So as the walls get smaller, the air gets compressed. We're taking all of the air, and now it's into a smaller space. And when you do that to air, you build up its pressure. So the pressure of the air inside the smaller house is greater. There's a lot more pressure, but there's a lot less volume. There's nowhere for me to go. Okay, I'm losing actual space to move around. Conversely, if I'm inside a house watching TV and the walls start to expand, there's going to be more volume, right? A bigger house. There's more room for the air to go. And then the air becomes less compressed and it can move around, and thus there's less pressure. So as the air has less pressure, it fills up the volume and you get larger volume. Think of a scuba tank. The scuba tank itself, theoretically, should only be able to hold as much air as the volume of the container allows. But what we now know, thanks to Boyle's law, is we can compress that air. So creating more pressure, less volume. So we can take all the air, compress it inside that scuba tank, and now the amount of air that might have filled this much can now take up less volume. It's going to be under greater pressure, but it's going to take up less volume, so we can still fill more air inside that scuba tank. Thank you.